These are the notes for 7.1, which is an introduction to probability. Before I start this video, let me just remind you to get a calculator. I don't have mine with me right this moment, but when we have our test, which is coming up, you're not going to be able to use a cell phone or a computer calculator. So you're going to have a handheld calculator. I've already mentioned that in previous videos. It's in the ICR, but make sure you get that calculator. Let's get started on these notes. Again, this is in the book, section 7.1, and it's also in Hawks, and you'll have a section of Hawks to do. Probability is the likelihood or the chance of something happening. Okay, so what is the chance that it's going to rain today? What is the probability that it's going to rain today? What is the likelihood that it's going to rain today? All of those things are the same wording. Probabilities are written as fractions, and they're always going to be reduced, okay? So make sure that you reduce your fraction. The top, okay, the numerator goes on the top. That's going to be the specific outcome you desire. And then the denominator, which goes on the bottom, is going to be the total outcomes available. And I'm going to explain that more in detail as we look at some examples. So some probabilities are written as a decimal. I typically write my probabilities as a fraction, but there are occasions where you might see it as a decimal. It's going to fall between 0. Now, if you have a probability of 0, that means exactly what you think. There is no chance at all of that occurring, okay? A probability of 0. For example, if you roll a fair die, what is the chance that you're going to roll an 8? 0. Because a fair die only has sides 1 through 6. So there's a 0 chance that you're going to roll an 8. Now, the opposite is true too. If you have a probability of 1, then that means there is an absolute definite chance of that occurring. Okay? 1 means it is a perfect probability. So, for example, what is the probability that I'm drawing a blank. What is the probability that you roll a fair die and you get a number? Okay, there's a 100% chance that you're going to get a number. Now, what that number is varies, but you are going to get a number if you roll a fair die. Okay, that wasn't a great example, but I'm sorry, I just can't think of a great one right now. But if you get a probability of 1, that means it's an absolute definite going to happen. Okay, let's move on. What is the probability? So number 1, or 1A, you toss a fair coin. In other words, a nickel, a quarter, a dime, a penny. And what is the probability that it lands on tails? Okay, go back up to the top. Right here, I've got my little notes. The top number, the numerator, is the specific outcome you want. So in this example, what do we want? We want tails. And how many tails are on a fair coin? 1. So that's what we want. And then the denominator is the total of all your options. So if you roll a fair coin, what are your total options? Well, your total option is heads or tails. So there would be 2 total options here. And so that would be 1 out of 2. The probability that you roll a fair coin and get a tail is 1 out of 2. Now, interestingly enough, if I ask you what's the chance you're going to get a heads, it's 1 out of 2 as well. B, you roll a fair die. Okay, so we're talking about the little game pieces that have 6 sides. And what is the probability that you're going to land on a 3? Well, you need to know this. A fair die has sides of 1, 2, 3, 4, 5, and 6. Those would be the options. I mean, every once in a while you get some random board game that's got like 8 sides, but we're talking about just the traditional fair die. And so what is the probability that you're going to land on a 3? Well, there's one option that you want. You want a 3. There's only one 3. And there are a total of 6 possible sides. So the probability would be 1 out of 6. C, now this one's a little bit different. You roll a fair die and it lands on an even side. Now, let me go up here. Let's see if I can change my color to blue. Go back up here to the top. Which of these numbers were even? Well, this is even, 4 is even, and 6 is even. So again, looking at our top instructions, the numerator should be the specific outcome you desire. Well, we want an even, and I just circled the evens. There are 3 evens. So there are 3 specific outcomes that I'm interested in. I can either roll a 2, I can roll a 4, or I can roll a 6. And there are, 2, 4, 6, those are the evens. And there are 6 total options. So 3 are the desired outcomes, 6 are your total. And that has to be reduced. Notice 3 out of 6 can be reduced, and so your answer would be 1/2. D, you roll a fair die. Again, we're still talking about the same thing, and it lands on a digit greater than 4. Okay, let's get a different color here. Let's go to green. All right, so which one of these are greater than 4? Well, 5 and 6 are my only options that are greater than 4. So I either need to roll a 5 or I need to roll a 6. That gives me 2 options. So the answer to D is I've got 2 options out of 6, which reduces again to 1 out of 3. The probability that you're going to get a number greater than 4 when you roll a fair die is 1 out of 3. E, you draw a letter from the alphabet and it is B. Well, you have to know how many letters are in the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. So there are 26 letters in the American English Standard Alphabet. So 26 letters in our alphabet. What is the chance that you're going to be? Well, B is what we want. There's only one B. And so it would be 1 out of 26. There's no other way to draw a B other than to get a B. Nothing else counts. F. Now, this is very, very, very important. Let me get my highlighter here. And if you are not familiar with a deck of cards, this is used a lot in this particular section and also on the exam. So if you're not familiar with a deck of cards, you either want to get a deck of cards or you want to look at the pictures that they have on page 306 of your textbook. But we're talking about a standard deck of cards you might play spades with, or I don't really play a lot of cards. That's the only card game I can think of. But anyway, if you're not familiar with cards, look at the book and you can see, what's going on with a deck of cards. But you draw 1 card from a standard deck and it is red. Okay? Well, if you know anything about cards, you've either got reds or blacks. Okay? There are 52 total cards in a deck. And half of those are red and the other half are black. So how many reds? Well, there are 26 reds out of 52 total cards, and that reduces to 1/2. So if you draw a card out of a standard deck, half of them are going to be red. And guess what? The other half are going to be black. G, there's a typo. You draw a card from a standard deck, and it is a 2. Well, there are 4 2s in a deck of cards. I can't draw this very well, but there are 4 2s in a deck. You have 2 reds, 2 blacks. So you have a red 2 of hearts. You have a red 2 of diamonds. You have a black 2 of spades and a black 2 of clubs. I hope that's right. Okay, I might have to redo this. But I know you have 4. And I know 2 are red and 2 are black. I might have messed my suits up. So if I mess my suits up, look in the book. I apologize. But 4 2s in a deck. So what we're going to do, we want a 2. We don't care if it's red or black. That's not the point. I should have just been quiet and not said so much, and I wouldn't have messed myself up. So we want 4 out of 52. Okay, and we can reduce that. 4 goes into 4 1 time. 4 goes into 52 13 times. There are 13. You've got like your ace, jack, queen, king, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 out of 13. So the chance you're going to draw a 2 is 1 out of 13. And the last one, there are 8 freshmen, 6 sophomores, 10 juniors, and 6 seniors in your high school. If you select one person at random to read the daily announcements, what is the probability that the student is a sophomore? Well, this one is a tiny bit different. Well, not really, but they didn't tell us the total. So remember, the numerator is what you want. So what we want is the student to be a sophomore. So we go up here and we say, okay, 6 are sophomores. So 6 goes on the top because that's what I want. On the bottom, we have to put our total. And we weren't given a total here, but we can add it up. So 8 plus 6 is 14. Plus 10 is 24. Plus 6 more is 30. So there are a total of 30 students in that high school. And that does reduce. 6 can be divided by 6, as well as 30 can be divided by 6. And so the answer is 1 out of 5. Okay? So that is your little tutorial on section 7.1. There are a couple other questions in Hawks, but I think that'll be enough to help you be successful.